Unit 3, Describing Features of Computer Vision Workloads on Azure. By the end of this unit, you should be able to identify common types of computer vision solution, and determine Azure tools and services for computer vision tasks. Lesson 1, Identifying Common Types of Computer Vision Solution. Introduction. In this lesson, we'll explore various computer vision workloads in Azure, focusing on how Azure's powerful tools and services enable image recognition, face and object detection, and optical character recognition, OCR. You'll discover how to apply these capabilities to real-world scenarios, enhancing applications with advanced visual analysis. Topic 1, Identifying Features of Image Classification Solutions. In this topic, we'll dive into image classification solutions, exploring how machine learning models can automatically categorize images into predefined classes. Image classification solutions. Image classification. It is a common computer vision problem that requires software to analyze an image to categorize, or classify, it. Image classification is a computer vision technique in which a model is trained to predict a class label for an image based on its contents. Examples: apple, banana, orange. These images were classified based on the fruit each contains. Models can be trained for multi-class classification, multi-label classification. In multi-class classification, there are multiple classes but each image can belong to only one class. In multi-label classification, an image might be associated with multiple labels. Azure AI Custom Vision. This service enables you to build your own computer vision models for image classification. Azure AI Custom Vision service is designed to help you extract information from images. It provides functionality that you can use for description and tag generation, determining an appropriate caption for an image, and identifying relevant tags that can be used as keywords to indicate its subject. Object detection. Detecting the presence and location of specific objects within the image. People detection. Detecting the presence, location, and features of people in the image. Image metadata, color, and type analysis. Determining the format and size of an image, its dominant color palette, and whether it contains clip art. Category identification. Identifying an appropriate categorization for the image, and if it contains any known landmarks. Background removal. Detecting the background in an image and output the image with the background transparent or a grayscale alpha matte image. Moderation rating. Determine if the image includes any adult or violent content. Optical character recognition. Reading text in the image. Smart thumbnail generation. Identifying the main region of interest in the image to create a smaller thumbnail version. To use the Azure AI Custom Vision service, you must provision two kinds of Azure resource. Training resource. To use the Azure AI Custom Vision service, you must provision two kinds of Azure resource. O training resource. O prediction resource. Prediction resource. To use the Azure AI Custom Vision service, you must provision two kinds of Azure resource. O training resource. O prediction resource. Train an image classifier. To train an image classification model with the Azure AI Custom Vision service, you can use the Azure AI Custom Vision portal, the Azure AI Custom Vision REST API or SDK, or a combination of both approaches. The portal provides a graphical interface that you can use. Create an image classification project for your model and associate it with a training course. Upload images, assigning class label tags to them. Review and edit tagged images. Review and edit tagged images. Test a trained model. Publish a trained model to a prediction resource. The REST API and SDKs enable you to perform the same tasks by writing code, which is useful if you need to automate model training and publishing as part of a DevOps process. Topic 2, Identifying Features of Object Detection Solutions. In this topic, we'll explore object detection solutions, where machine learning models identify and locate objects within images or videos. Object detection solutions. Object detection. It is a common vision problem that requires software to identify the location of specific classes of object in an image. Object detection is a form of computer vision which is trained to detect the presence and location of one or more classes of an object in an image. Two components to an object detection prediction. 1. The class label of each detected in the image. 2. The location, indicated as coordinates of a bounding box that encloses the object, of each object within the image. Provision Azure AI Custom Vision Service for Object Detection. 1. Training resource. 2. Prediction resource. Training resource. This is used to train your models. 1. An Azure AI Services multi-service source. 2. Azure AI Custom Vision, Training, Resource. Prediction resource. This is used by client applications to get predictions from your model. 1. Azure AI Services multi-service source. 2. Azure AI Custom Vision, Prediction, Resource. You can use Azure AI Services multi-service resource for both training and prediction, and you can mix and match resource types. If using a multi-service resource, the key and endpoint for both training and prediction will be the same. Train an object detector. Training methods. Use Azure AI Custom Vision Portal to upload and label images. Use REST API or SDK to write code for training tasks. Image classification model. It requires one or more tags that apply to the whole image. VS. Object detection model. It requires that each label consists of a tag and a region that defines the bounding box for each object in an image. The Azure AI Custom Vision Portal provides a graphical interface that you can use to label your training images. Considering options for labeling images. Easiest option, use the interactive interface in the Azure AI Custom Vision Portal. O automatically suggests regions containing objects. O assign tags or adjust bounding boxes by dragging. Training the model. O tag an initial batch of images. O use the Smart Labeler, can suggest not only the regions, but the classes of object they contain, tool for subsequent images. Alternative tools which can be used in assigning tasks to multiple team members. O Azure Machine Learning Studio. O Microsoft Visual Object Tagging Tool, VOTT. Bounding box measurement units. Adjusting output. Match measurement units expected by Azure AI Custom Vision API. Bounding box definition. 4 values, left, x, top, y, width, and height. Values represent coordinates and dimensions relative to the image size. Proportional values. O left, 0.1, 1/10 from the left edge. O top, 0.5, half the image height from the top. O width, 0.5, half the image width. O height, 0.25, quarter of the image height. Topic 2, Identifying features of object detection solutions. Topic 3, Identifying features of optical character recognition solutions. We will now delve into optical character recognition, OCR, solutions, where machine learning models convert printed or handwritten text in images into editable and searchable data. In this topic, you'll learn how Azure's OCR tools can efficiently extract text from documents, enhancing data accessibility and automation. Optical character recognition. Optical character recognition, OCR. This enables applications to extract information from photographs, scanned documents, and other sources of digitized text. Optical character recognition, OCR. It acts as the foundation for processing text in images. It also uses machine learning models to recognize text elements, letters, numerals, punctuation. Uses of optical character recognition. Improves speed and efficiency. O automates text processing. O eliminates manual data entry. Recognizes printed and written text. O note-taking. O digitizing medical records. O digitizing historical documents. O. Scanning checks for bank deposits. Azure AI Vision's OCR engine. Azure AI Vision service. O. Extracts machine-readable text from images. Read API, OCR engine. O. Powers text extraction from images, PDFs, and TIFF files. O. Optimized for general, non-document images. Recognition models. O. Uses latest models for text-heavy or visually noisy images. O. Automatically selects the appropriate model based on text lines, images with text, and handwriting. Bounding boxes. O. Identifies coordinates of text within an image. O. Detects and outlines text elements. Calling the Read API returns results arranged into the following hierarchy. Pages. O. One for each page of text. O. Includes information about page size and orientation. Lines. O. Lines of text on a page. Words. O. Words in a line of text. O. Includes bounding box coordinates and the text itself. Get started with Vision Studio on Azure. To use the Azure AI Vision service, you must first create a resource for it in your Azure subscription. You can use either of the following resource types. O. Azure AI Vision. O. Azure AI Services. It is a specific resource for Vision services. Use this resource type if you don't intend to use any other AI services, or if you want to track utilization and costs for your AI Vision resource separately. It is a general resource that includes Azure AI Vision along with many other Azure AI services such as Azure AI Language, Azure AI Speech, and others. Use this resource type if you plan to use multiple Azure AI services and want to simplify administration and development. Once you've created a resource, there are several ways to use Azure AI Vision's Read API. Vision Studio. REST API. Software Development Kits, SDKs. Python. JavaScript. C#. Azure AI Vision Studio. O. Access Azure AI Vision APIs via a graphical user interface. O. No coding required to get started. O. Select a default resource upon opening Vision Studio. O. Default resource must be an Azure AI Services resource, not an Azure AI Vision resource. O. You can select Optical Character Recognition, OCR, from the homepage and the Extract Text from Images tile to try out the Read OCR engine. O. Select Extract Text from Images to use the Read OCR engine. O. Usage costs incurred when results are returned. O. Use your own files or sample files. O. Read OCR engine returns detected attributes in bounding boxes. Behind the scenes of Azure AI Vision Studio. Image analysis. O. Analyzes features like people, text, and objects. O. Marks features with bounding boxes. Processing and results. O. Processes detected information. O. Returns results to the user. O. Raw results in JSON format. O. JSON includes bounding box locations and detected text. Building OCR applications. O. Vision Studio provides OCR examples. O. To build your own OCR application, use an SDK or REST API. Topic 4. Identifying features of facial detection and facial analysis solutions. In this topic, you'll learn how Azure's advanced tools can be used for applications such as emotion recognition, age estimation, and identifying individuals, enabling powerful insights from facial data. Face detection and analysis. Face detection and analysis is an area of artificial intelligence, AI, which uses algorithms to locate and analyze human faces in images or video content. Uses of face detection and analysis. Security. It can be used in building security applications, and smartphones operating systems for unlocking devices. Social media. It can be used in building security applications, and smartphones operating systems for unlocking devices. Intelligent monitoring. X. An automobile might include a system that monitors the driver's face to determine if the driver is looking at the road, looking at a mobile device, or shows signs of tiredness. Identity validation. X. An automobile might include a system that monitors the driver's face to determine if the driver is looking at the road, looking at a mobile device, or shows signs of tiredness. Missing persons. Using public camera systems, facial recognition can be used to identify if a missing person is in the image frame. Advertising. Using public camera systems, facial recognition can be used to identify if a missing person is in the image frame. Face detection involves identifying regions of an image containing a human face, typically by returning bounding box coordinates that form a rectangle around the face. Face analysis uses facial features like nose, eyes, eyebrows, and lips to train machine learning models for extracting additional information. Central/nose landmarks. Nose root left. Nose root right. Nose tip. Left side landmarks, viewer's left. Eyebrow left inner. Eyebrow left outer. Eye left top. Pupil left. Eye left outer. Eye left bottom. Eye left inner. Nose left alar top. Nose left alar out tip. Upper lip top. Upper lip bottom. Mouth left. Right side landmarks, viewer's right. Eyebrow right inner. Eyebrow right outer. Eye right top. Pupil right. Eye right outer. Eye right bottom. Eye right inner. Nose right alar top. Nose right alar out tip. Mouth right. Under lip top. Under lip bottom. Facial recognition. Facial recognition. An application of facial analysis. Trains the machine learning model so that it can detect those individuals in new images on which it wasn't trained. Improves efficiency, security, and customer experiences when used responsibly. Azure AI services you can use to detect and analyze faces. Azure AI Vision. It offers face detection and some basic face analysis, such as returning the bounding box coordinates around an image. Azure AI Video. It can be used to detect and identify faces in a video. Azure AI Face. It offers pre-built algorithms that can detect, recognize, and analyze faces. This offers the widest range of facial analysis capabilities. Face offers the widest range of facial analysis capabilities. Azure Face Service, Face Attributes. Accessories. Detects face accessories like headwear, glasses, and masks, providing a confidence score between 0 and 1 for each. Blur. How blurred the face is, which can be an indication of how likely the face is to be the main focus of the image. Exposure. Whether the image is underexposed or overexposed. This applies to the face in the image and not the overall image exposure. Noise. Refers to visual graininess or tiny dots in an image, often caused by high ISO settings in low light, reducing clarity. Glasses. Whether or not the person is wearing glasses. Head pose. The face's orientation in a 3D space. Occlusion. Determines if there might be objects blocking the face in the image. Mask. Indicates whether the face is wearing a mask. Uses of face service. Detect the location of faces in an image. Determine if a person is wearing glasses. Determine if there's occlusion, blur, noise, or over/under-exposure for any of the faces. Return the head pose coordinates for each face in an image. The limited access policy requires customers to submit an intake form to access additional Azure AI face service capabilities including the ability to compare faces for similarity. The ability to identify named individuals in an image. Azure resources for face. Face, used if only face services are needed or its usage and costs are to be tracked separately. Azure AI Services, a general resource used to simplify administration and development when using multiple Azure AI services. Considerations that can help improve the accuracy of the detection in the images. Image. Considerations that can help improve the accuracy of the detection in the images. File size. 6 MB or smaller. Face size. from 36x 36 pixels up to 4096x 4096 pixels. Other issues. Face detection can be hindered by extreme angles, lighting, or occlusion. Lesson 2, Identifying Azure Tools and Services for Computer Vision Tasks. Introduction. This lesson is designed to explore the various Azure tools and services designed to support computer vision tasks. It discusses how to leverage Azure's capabilities for image recognition, object detection, and facial analysis to build powerful, intelligent applications. Topic 1, Describing capabilities of the Azure AI Vision Service. In this topic, we'll explore Azure AI Vision Services, which offer powerful tools for analyzing and interpreting visual data. You'll learn how these services enable features like image classification, object detection, and optical character recognition, helping you build intelligent applications that understand and process visual information. Computer vision. It is one of the core areas of artificial intelligence, AI, and focuses on creating solutions that enable AI applications to see the world and make sense of it. Images and image processing. Before exploring the image processing and other computer vision capabilities, it's useful to consider what an image is in the context of data for a computer program. Images as pixel arrays. To a computer, an image is an array of numeric pixel values. The array consists of 7 rows and 7 columns, representing the pixel values for a 7x7 pixel image, also known as the image resolution. Each pixel has a value between 0, black, and 255, white, with values between these bounds representing shades of gray. Using filters to process images. A common way to perform image processing tasks is to apply filters that modify the pixel values of the image to create a visual effect. A filter is defined by one or more arrays of pixel values, called filter kernels. For example, you could define filter with a 3x3 kernel as shown in the image shown. The kernel is then convolved across the image, calculating a weighted sum for each 3x3 patch of pixels and assigning the result to a new image. It's easier to understand how the filtering works by exploring a step-by-step example. First, we apply the filter kernel to the top left patch of the image, multiplying each pixel value by the corresponding weight value in the kernel and adding the results. 0x-1, plus, 0x-1, plus, 0x-1, plus, 0x-1, plus, 0x8, plus, 0x-1, plus, 0x-1, plus, 0x-1, plus, 255x-1, equals minus 255. The result, minus 255, becomes the first value in a new array. Then we move the filter kernel along 1 pixel to the right and repeat the operation. 0x-1, plus, 0x-1, plus, 0x-1, plus, 0x-1, plus, 0x8, plus, 0x-1, plus, 0x-1, plus, 255x-1, plus, 255x-1, equals minus 510. Again, the result is added to the new array, which now contains 2 values. 255 and 510. The process is repeated until the filter has been convolved across the entire image, as shown in this animation. Machine learning for computer vision. Image filters are useful for applying effects and enhancing images in editing software. However, computer vision aims to extract meaningful insights rather than just modifying images. This requires training machine learning models to recognize features using large data sets. To see the effect of the filter more clearly, here's an example of the same filter applied to a real image. Original image. Filtered image. A filter is convolved across an image, generating a new array of values adjusted to fit the 0 to 255 pixel range. Since the filter doesn't cover the outer edges, padding, usually 0, is applied. The transformed array represents a new image where the filter enhances specific features, such as edges. This process, called convolutional filtering, is commonly used in image processing. One example is the Laplace filter, which highlights edges, but other filters can create effects like blurring, sharpening, and color inversion. A common machine learning model for computer vision is the convolutional neural network, CNN. CNNs use filters to extract features from images and then make predictions. In image classification, the model predicts what an image represents, such as an apple, banana, or orange. During training, filters start with random values and adjust over time to improve accuracy by learning features that distinguish different fruits. In image classification, the model predicts what an image represents, such as an apple, banana, or orange. During training, filters start with random values and adjust over time to improve accuracy by learning features that distinguish different fruits. During training, predicted probabilities are compared to actual class labels to calculate loss. The model adjusts neural network weights and filter kernels to minimize this loss. This process repeats over multiple epochs until optimal weights are learned. Once trained, the model saves these weights and can classify new images with unknown labels. CNN architectures include multiple convolutional layers, along with others that reduce the size of feature maps and adjust values. While simplified examples may omit these layers, the main idea is that filters extract numeric features that are used by neural networks for image classification. Transformers and multimodal models. Object detection models combine CNN feature extraction layers with the identification of regions of interest in images to locate multiple classes of object in the same image. CNNs have been at the core of computer vision solutions for many years. While they're commonly used to solve image classification problems as described previously, they're also the basis for more complex computer vision models. Transformers. CNN-based models have driven advances in computer vision, while transformers have revolutionized NLP by encoding words as vector-based embeddings. These embeddings position related words closer in a multidimensional space, enabling more sophisticated language models. Multimodal models. The success of transformers to build language models has led AI researchers to consider whether the same approach would be effective for image data. The result is the development of multimodal models, in which the model is trained using a large volume of captioned images, with no fixed labels. An image encoder extracts features from images based on pixel values and combines them with text embeddings created by a language encoder. The overall model encapsulates relationships between natural language token embeddings and image features, as shown in the photo. Microsoft Florence. The Microsoft Florence model is just such a model. Trained with huge volumes of captioned images from the internet, it includes both a language encoder and an image encoder. Florence is an example of a foundation model. In other words, a pre-trained general model on which you can build multiple adaptive models for specialist tasks. For example, you can use Florence as a foundation model for adaptive models that perform image classification, identifying to which category an image belongs. Object detection, locating individual objects within an image. Captioning, generating appropriate descriptions of images. Tagging, compiling a list of relevant text tags for an image. Azure AI Vision. Training computer vision models requires complex architecture, large data sets, and significant compute power. Azure AI Vision simplifies this with pre-built and customizable models, allowing both common tasks and custom solutions using your own images. Azure AI Vision resource types. Azure AI Vision, it is a dedicated resource for the Azure AI Vision service, ideal for standalone use. It helps track utilization and costs separately from other Azure AI services. Azure AI Services, it is a general resource that includes Azure AI Vision and other AI services like Language, Custom Vision, and Translator. It simplifies administration and development for users needing multiple AI services. Azure AI Vision Analysis Capabilities. OCR, Optical character recognition, OCR, extracting text from images. O-captions, generating captions and descriptions of images. O-detection, detection of thousands of common objects in images. O-tagging, tagging visual features in images. Note, all these capabilities can be performed in Azure AI Vision Studio. Optical character recognition. Azure AI Vision Service can use optical character recognition, OCR, capabilities to detect text in images. Consider this image of a nutrition label on a product in a grocery store as an example. Describing an image with captions. Azure AI Vision can analyze an image, evaluate the objects that are detected, and generate a human-readable phrase or sentence that can describe what was detected in the image. Detecting common objects in an image. Azure AI Vision can identify thousands of common objects in images. For example, when used to detect objects in the skateboarder image discussed previously, Azure AI Vision returns the following predictions. Skateboard, 90.4%. Person, 95.5%. The predictions include a confidence score that indicates the probability the model has calculated for the predicted objects. In addition to the detected object labels and their probabilities, Azure AI Vision returns bounding box coordinates that indicate the top, left, width, and height of the object detected. You can use these coordinates to determine where in the image each object was detected, as shown in the image. Image classification. An image classification model is used to predict the category, or class of an image. For example, you could train a model to determine which type of fruit is shown in an image, like so. Object classification. Object detection models detect and classify objects in an image, returning bounding box coordinates to locate each object. In addition to the built-in object detection capabilities in Azure AI Vision, you can train a custom object detection model with your own images. For example, you could use photographs of fruit to train a model that detects multiple fruits in an image, like so. Topic 1, Describing capabilities of the Azure AI Vision Service. Topic 2, Describing capabilities of the Azure AI Face Detection Service. Let's dive into Azure AI Face Detection Service, which allows applications to detect and analyze human faces in images. In this topic, you'll learn how this service can identify facial features, emotions, and even estimate age, enabling you to integrate advanced facial recognition capabilities into your solutions. Azure AI Vision Service. Azure AI Face Detection Service. Face detection, analysis, and recognition are all common computer vision challenges for AI systems. The ability to detect when a person is present, identify a person's facial location, or recognize an individual based on their facial features is a key way in which AI systems can exhibit human-like behavior and build empathy with users. Identify options for face detection analysis and identification. There are two Azure AI services that you can use to build solutions that detect faces or people in images. The Azure AI Vision Service for face detection. This enables you to detect people in an image, as well as returning a bounding box for its location. Face detection, with bounding box. Comprehensive facial feature analysis, including head pose, presence of spectacles, blur, facial landmarks, occlusion and others. Face comparison and verification. Facial recognition. Important. Limited access required. Facial recognition, identification, comparison, and verification need approval through a limited access policy. Responsible AI compliance, this policy aligns with the Responsible AI standard for ethical AI use. Restricted access, facial recognition features are covered in this module but are unavailable without limited access approval. Understand considerations for face analysis. AI applications require ethical considerations, especially those using facial data, which pose unique challenges. Key considerations include: facial data is personally identifiable, and should be considered sensitive and private. You should ensure that you have implemented adequate protection for facial data used for model training and inferencing. Ensure that users are informed about how their facial data is used and who will have access to it. Ensure that your face-based system can't be used in a manner that is prejudicial to individuals based on their appearance, or to unfairly target individuals. The JSON response illustrates what the Analysis 4.0 API returns when describing the example image based on its visual features. Face service capabilities. It provides comprehensive facial detection, analysis, and recognition. Face service functions. Face detection. For each detected face, the results include an ID that identifies the face and the bounding box coordinates indicating its location in the image. Face attribute analysis. You can return a wide range of facial attributes, including head pose, pitch, roll, and yaw orientation in 3D space. Glasses, no glasses, reading glasses, sunglasses, or swimming goggles. Blur, low, medium, or high. Exposure, underexposure, good exposure, or overexposure. Noise, visual noise in the image. Occlusion, objects obscuring the face. Accessories, glasses, headwear, mask. Quality for recognition, low, medium, or high. Facial landmark location, coordinates for key landmarks in relation to facial features, example, eye corners, pupils, tip of nose, and so on. Face service functions. Face comparison. You can compare faces across multiple images for similarity and verification. Facial recognition. You can train a model with a collection of faces belonging to specific individuals, and use the model to identify those people in new images. Facial liveness. Liveness can be used to determine if the input video is a real stream or a fake to prevent bad-intentioned individuals from spoofing the recognition system. Compare and match detected faces. When a face is detected by the face service, a unique ID is assigned to it and retained in the service resource for 24 hours. The ID is a GUID, with no indication of the individual's identity other than their facial features. Implement facial recognition. Steps in training a facial recognition model with the face service. 1. Create a person group that defines the set of individuals you want to identify, example, employees. 2. Add a person to the person group for everyone you want to identify. 3. Add detected faces from multiple images to each person. The IDs of these faces will no longer expire after 24 hours. 4. Train the model. The trained model is stored in your Face, or Azure AI Services, resource, and can be used by client applications to identify individuals in images. Verify the identity of a detected face. Analyze new images to find faces that are similar to a known, persisted face.